Hi, welcome to my new knowledge base video series. In this introduction video, I will be speaking about all the topics covered in the future sessions and a case study on autonomous robot. If you are watching this video, chances are you are here to learn microcontroller programming or to learn how to build a robot, or some of you might be interested in what is embedded system is all about. Most of you will have some kind of idea to automate something at your home, something like switching on the fan when temperature is high or turn on the lights whenever you enter a room. Some of you might want to build a robot which brings TV remote and chips packet to your couch. With all these ideas in head, along with the question where to start, how to learn, here are my videos answering those questions. The video series will cover case study on autonomous robot, which is dealt in the same video, introduction to embedded systems and microcontrollers, different IDEs, compilers and tools used in microcontroller programming, embedded C, interfacing microcontroller to various devices like LCD, GPS, Bluetooth, motors and sensors, usage of peripherals like ADC, PWM, timers, etc. Communication protocols like UART, SPI, USB, wireless, IR remote, robotic arm construction, power supplies like SMPS, batteries, voltage regulators, calculations for voltage regulators, basically the resistor calculation and power calculations, and a video on OpenCV for image processing. All those videos will have two parts. One is hardware construction and second is programming. In hardware part, I will show how to physically interface microcontroller and other peripherals. I'll show how to solder components, considerations in picking up the hardware, etc. In programming part, I will show how to configure microcontroller to communicate with peripherals connected and writing functions, and how to get the data from the devices. There will be a related video link which explains in-depth concept related to a particular video. The videos will be sequenced towards the construction of robotic arm, but parallelly there will be videos explaining different topics related to embedded system. Okay, let's look into case study object picking autonomous robot. The aim is to pick up the shape in the work area selected by user through his mobile. It is a complex system which involves image processing, communication to mobile, controlling robotic arm, driving the platform towards the objects. You have to manipulate the robotic arm to the right coordinates and pick the object. The three major parts of the robotic system is mechanical construction, electronics and power supply, intelligence or programming. These three parts represent different domains of knowledge required in order to complete this robotic system. Let's go a little deep into each part. Mechanical construction. This part includes construction of chassis and robotic arm. This involves designing the dimensions of chassis and robotic arm links depending on the work area. So you have to select the dimensions depending on where the objects are placed, how much the length of robotic arm should be in order to pick up the object in the work area. And again, you have to calculate weight to power ratio of motors and links. Links has to be steady enough in order to pick up the object weight, and motors has to be powerful enough to lift the entire arm. You should design and calculate links length in order to cover the specific area of the workspace. You could use CAD designs or just a white paper. There is a selection of materials involved like aluminum, plastic or wood. If you are selecting plastic, you could go for 3D printing or get it laser cut in acrylic sheets. Wood is also same, you can get it laser cutted. Robotic arm can be driven through motors or hydraulics dependent on power to weight ratio and efficiency. In case if you are building a robotic arm which picks up something like 10 kgs, it's better you have some powerful motors or go for hydraulics. For hobbyists, we'll stick to motors. When it comes to selection of motors, in market we have servo and dynamaxle actuators for robotic arm. We will stick to servo as it is very commonly available in hobby market and cheap. Dynamaxle actuators are precise, efficient but costly, and even the programming part is very different. We'll select gear motor for wheels for the chassis, which could be metal geared or plastic geared, which has 300 to 500 rpm depending on the speed what you require, but also we can control the speed of motors. And selection of wheels, either it can be track belt or omni wheel or a regular wheel which has a rubber tire. Let's look into electronics involved. We have to select a microcontroller or an embedded platform which are available in the market. So we could choose any microcontroller for this project if you are doing an image processing on a PC. But in case if you want to have image processing on the microcontroller itself, then you should select 32-bit ARM processors or a embedded platform which has ARM processor. So it also depends on the knowledge what you have. So you could choose any microcontroller which you are comfortable with. As I'm more inclined towards PIC, I'll take PIC microcontroller. Selection of all these microcontrollers depend on what are the functionalities you require. But today in the market, most of the microcontrollers comes with almost all the peripherals like ADC timers, PWMs, etc. I would suggest pick up whichever microcontroller you are comfortable with to start with. But in my tutorials, I'll select PIC microcontroller and I'll show programming with MPLAB. Then again comes the devices and components required. Like in this case study, we are communicating with mobile, so I'm selecting Bluetooth as the wireless communication. So we will require a Bluetooth radio module, and we have to interface the motors, so we need motor drivers. They are ICs which drives the motor, as microcontroller cannot drive the motors directly. And I'm using a distance sensor so as to I know how far the object is from my platform. And coming to the power supply, we could use SMPS or AC to DC adapters, batteries like lithium ion or lithium polymer. I'll cover these batteries power supply basically in a different video. You should also calculate how much power is required, as each servo motor consumes 800 milliamps at 5 to 6 volts, and there is also motors which consumes 300 milliamps to 1 amp depending on how powerful the motor is, which I'll cover in a separate video, how to select power supply and calculation of the wattage. Coming to programming part, this is where you write all the code for your robot to understand or to work according to your desire. Till now, with the knowledge on mechanical and electronics, you have created a dumb robot which is sitting without knowing what to do. Programming involves image processing to determine the objects on the work area, and microcontroller programming to drive the robot towards the objects and manipulating the robotic arm to pick the object. For image processing, you could write your own function to read the image and perform the operation on that and determine the objects, or we could use APIs like OpenCV, which is available for free, and use the APIs in order to get the objects locations and all. Depending on microcontroller what we have selected, in my case it's PIC 18, we will select IDE and compilers. So for PIC we have MPLAB, IDE from Microchip, and compilers like C18 or XC8 from the Microchip itself. And we would require a programming device which dumps the code, hex code, from our PC to the memory of the microcontroller. We should also integrate Bluetooth protocol to communicate with mobile, and also an application in the mobile for the user to select the shape. We should also understand that servo motor is controlled through PWM. PWM being pulse width modulation. Servo understands the width of the pulse what we have generated, positive pulse. So depending on the positive pulse, it changes the direction, or it turns its shaft to the angle. So servo basically runs from 0 to 180 degree. So pulse corresponding to 0 degree is 1 millisecond, and for 2 millisecond the servo will rotates its shaft to 180 degree. Regarding this PWM, I'll be covering in a different video. Then we have communication protocol, which has to be integrated to communicate with mobile. Communication protocol, here we are using Bluetooth, so we will require a Bluetooth radio module, so which sends and receives data to mobile, and we require a mobile app application for the user to select the shape. And for image processing, we have mathematics involved, like perspective transformation to convert virtual coordinate system to world coordinate system, and kinematics for controlling the arm. The kinematics is implemented in the microcontroller part, or in the microcontroller itself, and perspective transformation is something which is required for camera calibration and to determine the coordinates where the objects are. To start with, I will be using Pythagoras theorem and simple triangle completion using cosine law. This will be applicable only when camera is perpendicular to work area. Otherwise, we have to go for perspective transformation. With this, I'll end the session. To recap, I have spoken about the topics covered in the future sessions, and in the case study, I have explained all the knowledge required to bring out the robot into reality. Thank you for watching this video.